Hi guys, we're looking at our theorem 2. We're still in Euclidean geometry. So in this case we're looking for so we have diagram 1, 2 here, and we have 3. So we're looking at theorem 2. So let's say this was labeled as our A, we have B, we have C, and we have O. And O is our origin or a center. Same thing can apply here. We can have A, we can have A, B, C, and O, which is our origin. And we can have A, B, C, and we have our O as well. So we're looking at theorem 2. So theorem 2 states that an angle at the center of a circle is double the angle of the circumference if they are both subtended by the same arc. Simple. It means this angle B here is twice this angle here. This means if this angle B here is equal to 5, and then this angle here will be 10 because it's double. If this angle B here is equal to 10, then this angle here will be 20 because it's double. Same thing apply here. We have this angle equal to this, so this angle is twice that angle. So if this angle B here is 5, then this angle would be 10. Or if this angle here is 15, then this angle will be 30 because it's double that. Same thing applies here. This angle or this angle is twice C. So what will be if we have 5 here? If this angle C is 5, then this angle here would be 10 because it's double that angle. So that is what basic the theorem says. So this angle B here, or this angle O here, is twice B here. So we need to prove that. Basically we're proving that we need to prove that an angle O is equal to 2B. O is equal to twice B in this situation of if you're looking at sketch number 1. Same thing will apply for sketch number 2. If you're looking at sketch number 3, we're just trying to prove that angle O is equal to twice C. Okay, so I'm trying to use sketch number 1 to prove this. Let's look at our sketch number 1 here, where we have A, we have B, we have C. And then the first thing to do here, we need to do some construction. So we construct a line OB. So we're constructing a line OB. This is our line OB here. This is our line OB here, because this is our O, because that is our O. So we constructed a line OB, and the results are we're getting OB. So what can you say? We need to separate, because now you see there is a formation of this triangle here. So we have a triangle AOB, and we also have a triangle BOC. So we have two triangles now. So we can separate it to prove our theorem. As you can see here, I have already separated it. So what I will have, okay, from our triangle here, the original one, we can look and say this is O1 and this is O2. Okay, and then we can say this is B1 and this is B2. So what I have come up with, we have A and we have B. So this is B1, this is B but B1, and this is O here. So this is O, so this is O1, you can see. So we have A, B1 and O1. So this is our triangles that we constructed. Let's look at this one. So here we'll have C, B, but this B here to be B2, and we also have O. So this would be O2. This would be O2. So we need to prove this theorem here, because this is what we're saying, it's our theorem. So what can we do here? For everything that we do, we need to state a reason, because we're proving some theorems here. So what can we say by looking at the diagram? So geometry laws, can we state that? We can state that AO is equal to OB. AO is equal to OB. The reasoning is ready. Sorry, it's radius, because we're looking at radius. That's why we can say that. So it's radius. And then so we're saying that these two sides here are equal. If we're saying that these two sides are equal, it means we can say B1 is equal to A. B1 is indeed equal to A. What else can we say? Okay, there's something to remember here, because this is our angle. We're looking at A, B1, O. So we can say that O1 is equal to B1 B1 plus A. Yes, we can say that O1 is equal to B1 plus A. Why? Because this is our O1 here. This angle here is our O1. So an external angle of a triangle is equal to the sum of the opposite interior angles, of which is this one here. This goes a long way back. If you can remember, if you are having a situation like this, and this is your triangle, so this angle here is equal to the sum of these two angles, this one and that one. So we can say that I think you should have learned this in grade 10 or grade 11, that the external angle of a triangle is equal to the summation of the opposite internal angles, of which is these two angles here. Okay, so that is the reasoning. You can simple write that reasoning, right? Okay, so what else can we say? So we're done with this first diagram here. Let's look at this second diagram here. What can we say here is that we can say OB is equal to OB. We can say OB is equal to OC. Reasoning will be radius, so it's ready. What else can we say? Since these two are equal, we can say that B2 is equal to C. And since this is our O2, then we can say O2 is equal to B2 plus C. All right, so what are we looking for? We're looking at this. We need to find O1 plus O2. So now we need to add them. You see, now we have two equations. We have this equation, we can call it equation 1, and we can look at this equation and say it's equation 2. So we need to sum them. If we're summing them, we can say O2 plus O1. So what is our O2? Our O2 is B2 plus C. What is our O1? Our O1 is B1. It's B1 plus A. It's B1 plus A. So what can we do here? We have B1. What is our C? Our C from here, we say it's we have B2, sorry. Our C from here, we say it's B2. So this is plus B, B2, okay? And we also have plus B, B1. What is our A from here? We know that our A is B1. So we're just doing a substitution now. B1. So what does this give us? This gives us 2 B2 plus 2 B1. So we have 2, okay? That therefore, if you're looking at 2B2 plus 2B1, this is the same as, because you can see if you're looking at B1, B2, B1, B2 is here. B1, B2 is the same as B. So B1, B2 is the same as B. And then at the same time, if you're looking at O1, 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 O2, O1 plus O2, that is O. Hence, we can say we have O is equal to 2B. 2B. So it's proven, because you see B1 plus B2 plus B1, that is B, simple B. And then we have O, so this gives us O. This is the same as O, and summing this one is the same as B. Hence we have done our proof. We have proved that this triangle here is twice B. This triangle here is twice B. So that is our theorem, and we have proven it. So we have proved that this angle here, or this angle here, is twice B. Same thing will apply for the rest of the diagram. So we have done proving our theorem. Thank you so much for watching.